All right, so on example 1, the first thing we're going to do is reorganize our inequality so that everything is on one side and we have 0 on the other side. Then after we do that, we're going to find our boundary points, you'll see, and then we are going to chunk up our number line at those boundary points, and then we're going to test the chunks. So that means to test the chunks. For example, if you wanted to say, for some reason, evaluate your function at 3 to see if it's positive or negative, you can plug a 3 in to your function. Or remember, using your remainder theorem, you could do synthetic division if you wanted to test to see if that's going to be a positive or a negative. Okay, so keep that in mind. I'm going to scroll just a little bit here. And we're going to reorganize our polynomial inequality. First of all, let's just bring down the 5y squared plus 7y and the less than, because the first thing we need to do is run the 3 through. Now we're going to get everything on one side. So that is subtract 3y from both sides and then also subtract 12. All right, I'm not having a whole lot of room over here. I didn't save myself a lot of room. So we have 5y squared plus 4y. I almost just wrote 7y, but we need to combine those, don't we? 7y minus 3y is 4y, and then I'm going to bring over that minus 12, and then less than 0. And all I did was subtract some stuff, so there's no need to swap that inequality symbol around. All right, now we need to find the boundary points. So for the boundary points, and this is how we're going to chunk up that number line down there in blue. Okay, we're going to solve the 5y squared plus 4y minus 12 equals 0. Solve that equation. Now, we should be pretty good at that by now. Maybe that is a quadratic formula. Or let's try to factor this. And I'll tell you, you're not guaranteed to get this to be factorable, but I bet most times you are, because college algebra textbook authors are not jerks, okay? And so you probably will be able to find how this would work. Let's see. We need to find, it's going to have to multiply to give me a negative 12 for those last terms. And so I'm going to try let's go with like a positive 6 and a minus 2. 5y squared minus 10y plus 6y. Ooh, almost. I think if we adjust that where that's a minus and that one, other one is a plus, let's try this. 5y minus 6 and y plus 2. Mentally FOIL that out, and I'm liking it. Okay? So when we set 5y minus 6 equal to 0 and y plus 2 equal to 0, we're going to have boundary points at 6/5 and at negative 2. All right? So we're going to go locate those on our number line. Negative 2 is the smallest, so I'm going to put it right there. And 6/5 is the largest. Keep in mind 6/5 is, in decimal form, 1.2. Now that we chunked up that number line, what we're going to do now is we're going to test those chunks. Okay? So I'm going to say I want to do like, let me check. I'm going to use a different color. I want to use orange maybe. Okay? Let me check anything that's less than negative 2. Anything at all that's less than negative 2. Like you could do negative 3 if you wanted to. Okay? Test anything in between negative 2 and 6/5. Now, y'all, whenever you can check 0, that's the quickest thing to do. I need to test anything bigger than 1.2. Because the thing is it's all or nothing on these chunks of our number line. If anything greater than 1.2 or 6/5 would check, all those values that are greater than 6/5 would check. So I'm feeling like checking 5. I don't know why, but I know it's bigger than 1.2, so that's fair game. Now what I'm going to do is I'm going to go up here and test those back in, okay? And so if I take 5 multiplied by a -3 squared, which is a positive 9, plus 4 times -3, and then minus 12, is that going to be less than 0? That's the big question, okay? So I've got 45 minus 12 more. And y'all, 45 minus 24 is only like a positive 21 or something like that. And is that less than 0? No, 21 is bigger than 0. So that tells me that this portion of my number line over here is not part of my solution set. Nope. Okay? Now, this is why I love over here checking a 0. Is because when we go back up here and put a 0 in for y, oh my gosh, that's so easy. 5 times 0 plus 4 times 0 is just 0. So we would end up with -12 and bring down the less than 0. And you know what? That's a true statement. Yes. And so all values in between -2 and 1.2 are going to be part of our solution set. Okay? Next, when we go to check some kind of value that's bigger than 1.2, I chose 5. I don't know why, I just felt like it. I'm going to get 5 times 5 squared is 25 plus 4 times 5 minus 12. I'm going to see if that's less than 0, and there is no way that stuff's going to come out to be a negative, which is less than 0. 125 plus 20 is like 145 minus 12. That's definitely not less than 0. Nope. Okay? So my solution set consists of all values in between -2 and 6/5. Now, because the symbol is just a less than, we don't include those endpoints at -2 or at 6/5. Okay? So our solution set is written in interval notation. I'm going to scroll just a little bit, and maybe I'll have room to write that. Okay, I'll just write it above. Okay. Our solution set is going to be all the values from -2 up to 6/5. That's interval notation, or you could say -2 is less than all our values of y, which is less than 6/5. You could write it in that form as well. Okay, now, that's great, but let me show you another way that might be a little quicker. We'll get the same answer here. What we first want to do is, instead of like chunking up the number line and checking the chunks, what we're going to do is, and imagine this thing right here. This is your number line that we are checking. Okay? Now, what we've got going on here and here, okay, are our boundary points of -2 and of 6/5. So we're putting those on our number line. And we're going to still check those 3 chunks. But what we're going to do is we're going to pull these factors from here. I'm going to consider what is the sign of the factor 5y minus 6. Okay? And then I like to put a little like little dash thing here. And also, what is going to be the sign of the factor y plus 2? Is it positive or negative? That's all I'm asking for each of these 3 chunks. And then I'm going to see where the 5y minus 6 times y plus 2, where that comes out to be less than 0. Less than 0. And I'm doing it that way because that was my problem here. Less than 0. So we're basically wanting to see, where is this negative? That's, that's less than 0, right? Okay. So the first thing we have to do is we have to fill in, and let me do this maybe in red, okay? For any value of y that is less than a -2, like think about if that was a -3, for example, Negative 15 minus 6, that's going to be some negative. Okay? So like, I'm going to test like a negative 3 for these. Okay? Just kind of like I did over here. But I'm testing a negative 3 just into each of the factors. So when y is a negative 3 here, negative 3 plus 2, that's still a negative quantity. Okay? Let's move along and let's test something in between negative 2 and 6/5. Think about now when y is 0. When y is 0, the sign of 5y minus 6 is 0 minus 6, which that's a negative. And 0 plus 2 is a positive number, right? Okay, now I'm going to test anything bigger than 6/5, and you can test anything you want, but let me think about the 5. Okay, let me get in here, and let me try to put a 5. Erase that stuff out of there. Okay, let me put a 5 in here. So 5 and 5. Let's see, 25 minus 6, I don't really care what it is, I just know that's going to be positive. And if I take something bigger than 6/5 and add 2 to it, it's going to be positive. Now, what we're doing here is we're taking a factor times a factor. So think about this. What is a negative times a negative? A negative times a negative is a positive. What is a negative times a positive? Anytime you take a negative quantity and multiply that by a positive, you get a negative. And what is a positive times a positive? It's a positive. So then we're seeing here, where is this stuff going to be negative? Well, that's in this part of it right in here where it's negative. And so on our number line, it would be just this chunk right in here. So again, we say, well, the only values are going to be between negative 2, not including negative 2, but up to 6/5. So we can look at it kind of this way in terms of the signs, or you can chunk up the number line and check your chunks. I think this is a little quicker, okay? And it gives us probably less of an opportunity to mess something up because of signs. All right, and so we will focus our work on doing it this way. That's an ugly arrow, but okay. All right.